Hi, I'm Nushafi Asrabin Ramnan from AS1202E. I would like to introduce about topic related rates, which is subtopic in chapter application of differentiation. Before we proceed, let me introduce what is differentiation. Differentiation is a process of finding a derivative with respect to variable of x. What is related rates? Related rates is a process of finding a rate at which quantity relating that quantity to other quantity whose rate of change are known, usually change with respect to time.
My name is Muhammad Farid Menzan. Now I will explain the objective of related rate. First, to find the rate of change of one quantity, knowing the rate of change of another quantity. Second, to finding the rate of change of two or more related variables that are changing with the respect to the time.
Hello, my name is Vincent Inang and I'm from AS1202E. Today I'm gonna tell you the question is alright, let's go. The situation is a man and his son were watching a baseball game at a big stadium. They each have a height of 6 feet and 5 feet ball out of the stadium with rate of 4 feet per second of stadium like 66 feet above the ground. A1. Find at what rate is the length of the further shadow in feet per second. Second, then find the height of his son if rate of shadow length is 20/61 feet per second. And B, one total of at what rate is the tip of the father and his son shadow in feet per second. Alright, we need to highlight the key point of this question. First, this one. This is the height of his father, and this is the height of son. Alright, and we got a dx over dt here, and we got a height of stadium. This is height of stadium. Alright. So question A, we want to find a rate is the length of the father. We need to highlight this so we not forgotten what is the question one, and we need to, this one is very important, the unit. And second, we want to find the rate, the height of his son, and this is what it given for you to calculate. Is very important for you to do a calculation. And B, you want to find a total rate of his father and son. Remember that, and the unit. That's it.
Question A1. We need to find what rate is the length of the father shadow. It means we need to find the value of the x over dt. The first thing we need to do is to draw the diagram like this, and we label it. This is for height of the stadium light equal to 66 feet. This is for height of father equal to 6 feet. And this is for the father shadow. From this one diagram, we need to split into two. The first one is come from the big one, 66, x plus s, and theta. And the value can we get from this diagram is tangent theta equal to 66 over x plus s. The second one is come from the small one, 6, s, and theta. The value can we get from this diagram is tangent theta equal to 6 over s. The other information that can we get from the question is the value of the x over dt equal to 4 feet per second. Now we will go to the solution for this question. These two value is need to become equal each other. So 66 over x plus s equal to 6 over s. Then we do cross multiplication and we get 66s equal to 6x plus 6s. Then we simplify and we get 60s equal to 6x. Then we differentiate both sides and we get 60 ds over dt equal to 6 dx over dt. Then we substitute dx over dt with 4 and we get 60 ds over dt equal to 24. Then we bring 60 to the other side, become divide, and the value, and we get ds over dt equal to 2 over 5 feet per second. And that is the final answer for this question. Question A2. In this question, we need to find the height of sun, which is y, when the red length of sun shadow ds over dt equal to 20 over 61 feet per second. So the first thing that we need to do is to draw two diagrams like this and we label it. The first diagram we label as y, s, and tangent and theta, and you can get tan theta equal to y over s. For the second diagram, we label it as 66, x plus s and theta, and we can get tan theta equal to 66 over x plus s. Then these two values need to be equal to each other. So 66 over x plus s equal to y over s. Then we do the cross multiplication and we get 66s equal to yx plus ys. Then we put the same thing in one side and another thing in other side. So we get 66s minus ys equal to yx. Then we differentiate both sides and we get 66 ds over dt minus y ds over dt equal to y dx over dt. Then we substitute the value of ds over dt with 20 over 61 and the value of ds over dt with 4. And we get 1320 over 61 minus 20 over 61y equal to 4y. Then we simplify and we get 264 over 61y equal to 1320 over 61. Then to find the height of sun, which is y, so 264 over 61 bring to another side and we can get the value of y equal to 5 feet. So that is the final answer for this question.
How to answer this question? Father, you know that dx over dt is equal to 4 and ds over dt is equal to 2 over 5. You already have this value, so it easily that you can get dl over dt. Just plug in the value to this and plus, and you got this. Why do you got 20 plus 2 over 5? Because 4 is multiplied by 5 to same the denominator. So you got 20. Just plus and you got it 22 over 5 feet per second. Alright. For sun, you same as this. You got a dx over dt is equal to 4 and dx over dt 20 over 61. This is given by the question, so you can easily get the answer for this. Why you got 244? Because 4 is divided by 61 to same the denominator, so that you can plus it easily. So plus it 244 plus by 20, you got 264. So the denominator is 61, so it is 61 feet per second. Alright, this is the unit. Don't forget about the unit. If you don't put it, you get a wrong and or it minus 1 mark for it. So you got dl over dt for father and dl over dt of son. So you find total. So if total, you just plus this two value, so you get the answer. So this is it.
To sum up, application of differentiation like related rates is very useful in daily life, especially in science and mathematical fields like architecture and engineering. Moreover, with the use of these related rates, we can solve the problem which is the rate change in a small amount. These related rates also does not require complicated calculation, where it just need to differentiate with respect to time. If there are many variables to differentiate, just use chain rule to solve the problem. Alright, that's all from us.